Okay, guys, as I mentioned, this is part of module 3. It was part of the previous material we've covered last semester also. Now, it's on establishing an association between analysis classes. Now, in this section, I'm not going to go through all of it. We're going to upload the video and it's going to be made available later on for our friends who's not here. I don't know where they are. Now, as I asked the question is about what is the output of this step? It ultimately is going to become a class diagram. What is the components we have in a class diagram? Well, you at least need to have the classes. Okay? So over here we have a class. We also have our association. We can have multiplicity. Okay. What else? Attributes. Where does the attributes go? Just under the name. So, attributes. What else? The operations. Okay. Now, where does the class name go? Where do we get the class name? Where do we see it? So for example, from our diagram we can start to place in the actual classes, the associations, the attributes, the operations. Can we really define operations where we are now? Not yet. Why not? The next module we're going to cover next week is going to be about distributing the use case behavior. What is behavior? The operations. So, by doing that, we will then be looking at distributing and assigning operations to our classes. For now, it will only be about creating the diagram and looking at the associations and the communication between them. Okay. So guys, you will see that I've prepared a long walkthrough. You've seen it last semester. And the walkthrough goes about all of it. Structure of UML2 diagrams, static structure and the dynamic diagrams. Then also the class diagram. So, then there's also mention about associations, aggregation, your composition, all of that. And how do you start to pick this up? It was addressed in the presentation. And you can find a lot of the information from the presentation. But I feel that the presentation is just an introduction to it almost. Okay. This was taken from a UML presentation created and placed on Developer Works from IBM. Okay. So, as part of this, there's also an exercise at the bottom of that. So, we have now seen and looked at it, and from this we can see how should a class be represented. From that, I can see that the class name is there, these attributes, and these operations. It is not always in analysis that we can give it the signature or the full signature. So we can't always go and say, but what is the returning data type going to be? Or is it private or public? Okay. So
you say design attributes like encapsulation and data types are
no, it is expressed, it's still indicated. So you mean the question is, do we indicate design attributes in a class? Okay. Have we selected the programming language, or where is it going? Is all attributes the same between all languages? Not really. So one of the challenges in this is, especially you making a very early decision about it, but you don't know the implementation language yet. So for example, a owner and the balance was, in this case, a string for the owner, and the balance is $. Do we really have a data type called $? No. Yeah, that would probably be a use-defined one, but is it even a good one? No. Okay, so this is becoming a design thing where you then later on look at the programming language, the implementation, where is it going to work on? Because then we also have inheritance and the indication of inheritance in a diagram. Now, what is the point of inheritance? What did you inherit from your parents? Certain genes, okay? What genes? Your skin color. Okay? Did you inherit some personality traits?
choice.
Is that choice? I don't know if it's always choice.
It's culture.
I have two boys, and the youngest one is Dewald, and I don't know if always what he's going through is just inherited, or is it something that he learned from me. But there's things which you can see in him where he's mimicking you, even though you've not shown him that. Now, why I'm mentioning that is because even in programming we have inheritance. Now, if I have to indicate inheritance, you will see we have a line that actually is it looks like an association, but has a full closed arrowhead pointing to the parent. What does that tell us? That we are now inheriting some attributes and operations from our parent. And the children can be performing some of the features, the functionality of the parent. Okay. Is it something we see in a class diagram a lot? Do you see it a lot in a class diagram? In your initial class diagram, will you see it? Yeah. Will you see it in the initial class diagram? No. Later on, you start to discover more things about it. But in your initial class diagram, you just might see it as just plain class with association. But as you start to discover attributes, you get to the place of seeing, but I can rather form some form of generalization structure, saying because this will be my parent, and this will be the children, and the children inherit some features.
You can get it from with the classes
So you're saying you can get it when the class is performing more operations than it needs to. But those are things that you don't initially see. If you just create your diagram, you don't always see it as the first pass to it. So when you go on, you will start to discover it and see more of it. Okay. So then there's also mention about associations, and in this case they're talking about bidirectional associations. What does bidirection mean? It means that we're going to be communicating in both directions. Can we make a distinction about which direction of communication is the most important? No. So that is why we're seeing that it is happening in both directions. A flight is assigned either a plane or no plane. Either there's going to be a flight or no flight. A plane can have 0 or many flights. Now you can get to one another by using each other really to point back to it. But on this diagram we see new things. We can start to see the multiplicity. We can see the names there. What does those names tell us? What is the multiplicity that we can see? Multiplicity indicates what to us? Multiplicity indicates how many of one class is interacting with the other one. So if we read the relationship from plane to flight, what are we seeing from that? A plane is assigned 0 or many different flights. Okay. What types of multiplicity do we have? There's a short list of multiplicity, and we have 0 or 1, only 1, 0 more, 0 more. It can be indicated in 2 different ways, or 1 or more. You can even have specific ranges. Okay. Now then we have a unidirectional or directed association. If you create this in a class diagram using the software, it would say to you directional association. Okay. So in this case, the two classes which we're still seeing is that they are related to each other. But we only have communication in one direction. And in this case, the overdrawn accounts report pulls that information from the bank account. Okay, so there's a specific direction in that communication. And the bank account don't really need to know anything about the accounts reports. But this guy uses the bank account to build up the list for us, or to build up that report. Okay. So in that case, there's a direction or choice in direction which is made. Do you see this often in a diagram? Is all of your relationships going to be bidirectional? Some may probably be bidirectional. Some will also be directed associations or even aggregation. Okay. Now, the other day we looked at it again in association class. What does that tell us? Association class tells us, but we have a class here on the association, and this class captures information about the association. Okay. Now, Because this information, if we take this as mileage credit, and it captures the bonus miles, the base miles, but that information does not really belong in either one of the two other classes. They,
This information comes from the two of them.
no, it's almost like it's additional information. So the question was, this information, does it come from either one of the two classes? And no. That information in that class is really just a matter of it describing the relationship in more detail. From this we can see that a flight can have passengers and they can be considered frequent flyers. And a frequent flyer can fly on 0 or many flights. So we really start to see that there's a many-to-many relationship. And a lot of times when you have a relationship like that, you will create a associative clause in the middle. This is what is going to become of this. But initially may just be indicated like this. But this information which we have here do not really belong in either one of the two classes. So they will be placed in a class which describe the relationship, the association. Okay. Any questions on this?
But where did you get that information? Because if we cannot have the information for the both of them, where did you get that information? Who can give the association between the two classes?
Okay, so the question is, where did we get this information? Because if it does not really fit with either one of the two classes, did we see it possibly on the paper, in our documentation? Yes. When we get to our example a bit later, I'll show you that there's a case of this really. Is there at any place, just to put your mind on that, is in our example, can we see the quantity of products which you possibly buying? Okay, we're going to get there. Now, any other questions before we go on? Then there was also mention again about aggregation and the whole two-part relationship in all of that. The test on this, it says to us, but when we see all of that, it talks about it, we start to see, when we look at about something like this, is a wheel part of a car? So if you start to see and you start to look at through your documentation and you see the phrase is part of or part of, that you start to realize, but objects of this thing is part of that thing. It may start to point to you in the direction of aggregation and even composition. Okay. So those words are not always used in the use case specification in your product documentation. But it may be words which you can find, but it can be words which you can find when you actually start to review the classes. If this product, if this car and wheel was part of a product manufacturing line where we're making cars, and I start to review the classes which I have, then I would realize, but my wheels, my items is part of the final product which we're producing. Okay, so in that case, it starts to point us in the direction of aggregation. Okay, now because aggregation is also still a relationship, there is multiplicity on a diagram. Okay, now what we're also seeing is that we start to see the role names or association names which can be used, but in this case they've used the role names. Which one should you use most often? Role names or association names? Association name is the easy one because it's the one that is just written on the line. And it just tells you, but this class is associated to that one in that specific way. But roles tells us the face, or what actually this one is playing towards the other one. Now, in programming, we tend to actually like the role names a lot more, because the role name then later on can be used as the object name which is used when we're creating this relationship. So even in the previous ones, now earlier diagrams, over here we could see flights and passengers. Those are role names. Okay, it's not association names. Guys, when do we make something composition? And how is composition indicated? How is it different than aggregation?
You can see that one of them is part of the other one.
Okay, so when one is part of the other one?
The department is part of the company.
Okay, so when the department is part of the company, what else? How is it indicated?
And the company can be, the company, no, the department can not have a company, something like that.
Okay, so that
Only one can exist within the other. If the other one dies, the whole thing dies.
okay, so if the one dies, the other thing dies. Okay.
Like the company can be composition and department aggregation.
So what we're seeing from this, the company is the aggregate, and the department is the parts. Keep in mind that company is still indicated on this side by our diamond. What does the diamond tell us? It tells us the aggregate. And the other side is then going to tell us the actual parts of the aggregate. So that department is part of the company. But in our diagram, we're also seeing this difference. What does that filled in one mean? What does it tell us? Composition. Okay, composition also means to us in a diagram that you can't have the one without the other. Okay, so I cannot have a company with actually having a department or some unit. And when you can't have a department without actually having a company or place where these people belong. Okay. Now, again, it's indicated by the same rule as aggregation. Is part of helps us, but then we see that there's a stronger link. You can't have the one without the other.
Yeah, means that composition and aggregation they need each other.
So, do they need each other? Which one becomes first?
The department needs the company.
No, the question more is about which one. When we start to identify, do we first identify aggregation or composition? Both of them really uses the same rule on department is part of a company. You see, I'm still using that same test on seeing the aggregate rule. But now I'm also seeing, but you can't have the company without a department. You can't have a department without a company. Okay. If we had to model the car one, and we're saying that we want to have functional cars, which we're selling, can you sell a car without wheels? If this is a inspector car or a rental agency, you can't sell or rent a vehicle without wheels. So in that case, you might have also realized, but according to the business rules and what I'm seeing in the business, I might need to model this rather as composition, not just plain aggregation. So we can't make a distinction really about which one is more important or which one is going to be identified first. But I can start to see, I can still use the same rules. This one is part of the other one. And then from that I can see, but there's a strong coincident lifetime. You can't have the one without the other. Yes.
The first one, for the, only for the aggregation, we say that one cannot live without the other. But with the aggregation and composition too, the
No.
same thing. What's the difference?
No, it's not totally the same thing. It's a good question, but I think what we're missing is aggregation is just telling us that we have a whole two-part relationship. It doesn't really talk about the actual fact that we might have a strong coincident lifetime, meaning that you can have the one without the other. In this case, we have composition. Now, composition is also a form of aggregation. It's a form of aggregation. Now, plain aggregation really tells us that the wheels is part of a car, that, but it doesn't talk about the composition portion about it. Okay. Any other questions on this one? Now, then they talk about reflexive associations. Reflexive means it's the same as one or unidirectional, not unidirectional, a relationship with just one class. Okay, so what we're seeing is that objects of the one class is related to other objects of the same class. In this case, an employee, what role is he playing? He's the manager. And he manages 0 or many other employees. Do we need two classes to manage or model the same thing? No, because they are both the same stuff. I mean, you use the same attributes to describe the employees. I don't need to model it as separate classes. But I can just put a proper relationship to model that this one is related in that. Okay.
So, sir,
Yes.
here we just want to talk about, we have a class, the employee. We mention what the employee does, or what is it, what is the role of the employee, or, I don't know, because this association, I don't understand. If we have a class,
Yeah.
the employee is a manager, what he does, he manages.
Okay, so from what are we seeing in this? We have one class, and the class stays employee. But in the business rules on the place where we're modeling this is one of the employees, an object from that, is overseeing other employees. So that is really one object is related to other objects of that same class. So that association, just the line that goes like that, is just telling us that this one class is related to the same class again. Okay. Now again, because it's association, we can have multiplicity and role names and all of that again on our diagram. Did I answer you? Okay. So guys, next it talks about the visibility in our diagrams. And from that we can start to see public, protected, private, and package-based scope. Is this something you normally make in analysis? The distinction already? No. Again, We don't know the implementation language because not all implementation languages support the same type of visibility, and they implement it differently. Okay. But what we will note from this, we can start to indicate it with the following symbols. The plus sign for public, dash for protected, dash for private, and the tilde for the package. So then there's again about roles. So just as an example to this, if the class was employee and the manager is an object in the employee, what role is he playing? He manages other employees. Okay. So the purpose of the role later on, when we translate this to actual code, means that this manages or manager or the role which he plays will become an object in your employee class to create a relationship between the manager, between the two employees of the same class. Okay. This is something we will look at again later on. So guys, how do we apply this, what we've gone through now, to our class diagram? Which classes do we have? Last week we looked at it a bit, and if we look at the use case place order, what classes do we have? What classes can you recall do we have from this? So those are the two easy ones, the place order form and controller. They're the easy ones. What other classes do we have? This being boundary and control class. Entities. Where can we find the entities? In here we would probably have gone through the noun extraction and the CRC codes, and we would have discovered that we have the order, the item, and customization options. Okay. Those are the classes that we can find for our class diagram from just looking at our specification. The two easy ones were form and controller, because they are the boundary class and the control class. The entities, we had to do the noun extraction and the CRC codes to get them. But that, we finished. It's part of the handout. Okay. When we create the class diagram, what do we start to see? What will be our relationships? Between which classes are we going to have relationships? Boundary and? Okay, so we are seeing that our boundary is going to take a different color. Boundary is communicating with our controller. Okay, what else? Can the boundary talk directly to the entity? Okay. You remember that our controller is there to capture the behavior of a use case. If we throw away all of the logic, all the behavior, who's going to make the decision about what should we retrieve, what should we display? So the next place of communication should be from the controller to the order, to the item, and to customization option. Okay. Where can we find the multiplicity? Anyone have an idea? Where can we find the multiplicity? If we had to look at the relationship between order and item, or even item and all of it. If you have an order and you're placing an order, how many items can you buy? Would you like to limit the customer? Does it make business sense to limit them? When I was still playing computer games competitively, we once went to McDonald's and bought something like 60 hamburgers. And if two people go there and go to McDonald's and you ask them, okay, I want to buy 60 hamburgers, they look at you like you're crazy. You're lying. Especially if you try and go through a drive-through. They don't like it. Okay. So if we had to look at the multiplicity between order and item, what would that be? Okay. So if we just look at those two entities quickly, what will be our multiplicity? Can you have an order without items? Can you have an order without items? So at least the multiplicity on this side should be 1. But the maximum which can be part of the order, we don't really know. Things which we might need to consider is health reasons that we possibly would limit it. Okay. How many items? An item can be part of how many orders? If we're selling a hamburger, how many times can someone buy the hamburger? Many times. What is the minimum? Well, we actually don't know. Why did you say 1?
Because we are starting with that. Why? You cannot make an order.
You cannot make an order without.
Items.
A,
And then if you have items, the items is here for you to make an order. So you must start for something.
but the problem about that becomes when you start to insert data, it becomes a bit of a problem. One of the two sides will be more important. You can't say that you will have an item, but before I can have this item, I must have an order also for it. When I create an item, I'm going to have one order for it. Okay, so what have we done now to identify the multiplicity and the relationship? What did we do? What did we apply? Okay. Okay, guys, what approach did we apply to identify the relationship? We looked at the classes which we had already. Okay. Then we looked at things which we know from the business domain. Okay. Sometimes we don't know enough information from the business domain and we might need to read up a bit to start to understand it. You might need to go and speak to an expert about the business. But in this case, we've seen places like this. We've bought from them a few times in our life, I assumed. Okay. Now the question is, can we start to look at this from an aggregation perspective? Can we? Is there some form of aggregation? How would we test for it? How would we test for it? By using the phrase, is part of. An order, is it part of an item? Bring me an item and show me the order it's part of. Okay. So, an item, is it part of an order? So, this one we can start to see, but there's some form of aggregation. I'm not drawing it there. So that we can look at the two different ones. Okay, so aggregation, we've mentioned now that it's indicated by this diamond. Is it composition? No. Because the item is still going to be existing without the order later on, or even before the order it exists. Okay.
So is it correct to have only aggregation about the association, like put those multiplicities in the aggregation, rather than having two?
So the question is it correct to rip out the association and only leave the aggregation relationship with its multiplicity? It may start to become and look a bit funny, especially when you try to implement this later on. What would be the multiplicity still on this side? Would probably still be too many. One too many there. Okay. But what we now start to see is this becomes shared aggregation. And that's not really right. So we need to start to reevaluate it and see, although I can apply this rule of the item being part of an order, it doesn't mean and doesn't make it really aggregation. Okay. So you'll see in part of the presentation there were more rules. No. So the second bullet, yeah, tells us aggregation should be used only where the parts are incomplete outside the context of the whole. So although we could go and say the item is part of an order, is the item incomplete? Without being connected to the order. If we look at this, is the item incomplete without looking at the order? The item is already complete. It's already giving us enough detail about the actual order. Okay, so in that case, we might start to see, but our decision based on aggregation would probably not be right. Okay. Yes.
Yes, I was saying that for the order to take place, the items must exist first. It's like we cannot say that the order is not part of the items. It's like if there is no order, the items still exist.
So the question about is that for us to say that that relationship, the order exists, there must be items. Yes, that is what we've indicated with our multiplicity also. Because our multiplicity is saying is we have an order. And to have an order, we can have one or many items part of the order. Okay. So just be careful when you're using aggregation to also take into consideration the rule or the guideline which is stated there. It should only be used where the parts are incomplete outside the context of the whole. Okay, so what happened there? That part, in that case, the item was already complete enough. It was in a lot more detail. Okay. Now, guys, how can we identify the rest of relationships? Where's the quantity of items that we buy? Yes. If we look at the attribute, just quantity. Where should it become part of? Is it part of the order? Is it part of the item? Does it belong in either one of the two? Keep in mind that this is a many-to-many relationship. What do we see with many-to-many relationships? You remember this guy? Okay, that is the place where we start to see associative or interstables or attributes which is describing the relationship. Because the quantity, what does it describe? It describes the relationship. Okay. So in that case, we start to see, but the quantity do not fit with the order directly or the item directly. But it's now used to describe how many objects we are buying of a specific item. Any question on what we've done so far? What would be the relationship between our boundary clauses? If we had to look at the relationship, if we had to look at that relationship, we now mentioned earlier on that there is a relationship between the place order form and the controller. We've mentioned that. But what is the relationship? So very easily, we can go and start to see that there's association. Is it aggregation or composition or any of those? Not a lot of the time. Okay, you might just model this as association. What would be the multiplicity? For this controller, how many forms can we have? Can it be used on many different counters, many different forms? Possibly. This form, is it going to work with many different controllers or one specific controller? Say again? Why can it?
If the system is complex or too large, it can work with two controllers or more than two controllers.
Okay, but which two? Why two? Is two now an arbitrary number you decided on? What about if there's 3 counters? So going to now say, but 1 to 3. Okay. A lot of times we can even just say 1 to many or 1 to 1. This form is going to be used on only one controller. This controller is going to interact with only one particular form. Okay. But this is decisions which will be expanded, especially when you go to design, because of the number of user interfaces that you are looking at. Okay. If you do this for a web-based system, or even a mobile system, or a Windows Forms application, the number of user interfaces which you might have may be different, maybe more or less. Okay, so, but they can still be interacting with either one class or many classes later on. Okay, because of the complexity of your system, you can structure it even. Okay. Now the relationship between from the controller to your entities, what would that be? From our initial work, we said that the controller is going to interact with the order, the item, the customization option. Okay, so in our diagram, we can expand this, and we can have our controller to other classes. If we just take and say, okay, but we have the order. What are we seeing there? What would be the relationship? So the relationship very easily is going to be controller to order, multiplicity. Now don't whisper, I can't hear you. Controller is going to interact with how many orders? Can it generate many orders? Okay, so it can generate many different orders. But this order is going to interact with only that order which it belongs to, or is part of that use case. Okay. Is there a minimum on this side, on the order side? The place order controller is creating an order. So in that case, we're talking about 1. But it can also retrieve the many different orders, possibly. Okay. So, do we possibly have aggregation and composition here? Is the order part of the controller? No, because it's actually 2 different classes having different scope. Entity and controller. So, if we now had to add our item in here, what are we seeing? We know that there is a relationship from the previous work between the item and the order. And from that, we went and said the order as 1 to many items and the item 0 to many. So we can go back this side. Okay. So we are putting that information together in creating our full diagram. Okay. Guys, any questions? Why don't we see generalization? Do we see generalization? Is there a place for generalization here? We don't know enough really yet from the entity classes. For example, the item. Are we going to make a distinction between the different items and how we possibly handled it? We don't know enough about it yet. Okay. So it's one of the reasons why we don't see generalization. Any questions? Okay. Guys, so as an output for this week, one of the things which you should actually have been done from last semester is to create a class diagram. Now, you should now be able to go and model this in the software, and you can take it in and go and model it as a complete diagram. Okay, I think what we will do is we will create an exercise, and you can then upload your work for this walkthrough your class diagram or your interpretation to this class diagram for this week. Okay. Any questions?
I didn't do the last part. This week.
Okay, for this week, we are going to create this guy and then also possibly submit it, get you to submit it as a practical portion so that you actually have modeled, so that you play a bit with the relationships and see what is the differences, what does it do. Okay, and that then we can see, but you have done it. Okay. Guys, so you will only have a test again this week on this particular module. Okay.
Question. Like the first one.
Similar to the first one. This is just to reiterate, this is now becoming a continuous assessment module, meaning that you will be assessed every week on the module which you have covered. Okay. You have one assessment which is scheduled during the week. If you miss that assessment, you need to see Vanessa also to schedule a time for you to write the second opportunity. Okay. There is also a formative one which will be made available, which must then just be written before the summative one. Okay. Any last questions? Going, gone.